For the solution stoichiometry assignment, you will find three types of questions. The first type of question will be like this, where we'll ask to find the mass percent of magnesium carbonate from an impure sample. But we're going to be using solution stoichiometry because we have a volume of 28.2 milliliters of a 0.179 molar solution of hydrochloric acid that's reacting with the impure magnesium carbonate. This starts off by giving you an unbalanced equation, but I balanced it real quickly. So for every 1 mole of magnesium carbonate, there's 2 moles of hydrochloric acid. It gives you 1 mole of magnesium chloride, 1 mole of carbon dioxide, and 1 mole of water. And this is because this forms carbonic, the HCl and CO3 2 minus combined to form carbonic acid, which breaks down into CO2 and water. Okay, just like any other solution stoichiometry that we're going to do, we're going to start with the volume, the 28.2 milliliters of HCl, and convert that to liters. From liters, we're going to multiply by the molarity to get the moles, so 0.179 moles of HCl per 1 liter of HCl. And now we use our stoichiometry, the 2 moles of HCl on the bottom and 1 mole of magnesium carbonate on top, and we can multiply by the mass of magnesium carbonate per moles, which is 84.32 grams of magnesium carbonate per 1 mole of magnesium carbonate. This tells us that 28.2 milliliters of the 0.179 molar hydrochloric acid solution reacted with 0.213 grams of magnesium carbonate. To find out the mass percent, you'll take the 0.213 grams of magnesium carbonate and divide by 0.770 grams of impure magnesium carbonate and multiply by 100%. This gives us 27.6%. This question is very similar to a question we asked in the reaction stoichiometry, but here we're dealing with solution stoichiometry. For question type 2, consider the unbalanced equation above. What is the concentration of the original aluminum chloride solution if 17 milliliters of that solution reacts with 53.6 milliliters of a 0.167 molar silver 1 nitrate solution? So I went and balanced this equation real quick. 1 mole of aluminum chloride is equal to 3 moles of silver nitrate. That gives us 3 moles of silver chloride and 1 mole of aluminum nitrate. Okay, so now that we have the equation balanced, we're just going to start with the 53.6 milliliters of silver 1 nitrate and convert that to moles of aluminum chloride. So we have to divide by 1,000 milliliters per 1 liter of silver 1 nitrate, multiply by the molar mass, 0.167, the molarity, 0.167 moles of silver 1 nitrate per 1 liter of silver 1 nitrate. Then use our stoichiometry. So there's 1 mole of aluminum chloride per 3 moles of silver nitrate. That's going to give us 0.00298 moles of AlCl3. Notice I kept 1 additional sig fig because I don't want to have any rounding errors yet. Now the 17 milliliters should have 3 significant figures on here. So we're just going to go ahead and convert that to liters. So 17 milliliters divided by 1,000 milliliters per 1 liter is going to come out to be 0.0170 liters. So now we're going to take the 0.002984 moles of AlCl3 and divide by 0.0170 liters, and that should give us a molarity of 0.176 molar AlCl3. So that should be the original molarity that we have in our question. Now, for question type 3, we're asked to solve things a little bit differently. Consider the unbalanced equation above. What is the concentration of the original KOH solution if 94 milliliters of the KOH solution reacts with 2.5 grams of phosphoric acid? Okay, so we have to go from grams of phosphoric acid to moles of phosphoric acid to moles of KOH, and then to molarity of KOH. So we need to balance our equation. So for every 1 mole of phosphoric acid, we have 3 moles of KOH, which produces 1 mole of potassium phosphate and 3 moles of water. So we take our 2.50 grams of H3PO4. We find the molar mass, which turns out to be 98.0 grams of H3PO4 for every 1 mole of H3PO4. Use our stoichiometry here, so 1 mole of H3PO4 gives me 3 moles of KOH. This is going to give me 0.07653 moles of KOH. Now, I'm going to show you a trick here. You can then take this, divide by the 94 milliliters, and multiply by 1,000 milliliters per 1 liter to get the molarity as 0.814 molar KOH. Okay, so I hope that helps.